Okay, 5.5, making connection and instantaneous rate of change. So see the height in meter of a car above the ground is of the Ferry wheel is given to you. And here is height, h is height, and the t is the time. So it gives you the height at each time. Determine the average rate of change. So average rate of change from 5 seconds to 10 seconds is going to be y2 minus y1 divided by x2 minus x1. Your y is h. So your h at 10 seconds minus the height at 5 seconds divided by 10 minus 5. h10 means simply instead of the t here, you see, you put what? You put 10. h5 means instead of t, you put 5. So you use your calculator, and here what you get, this is the average rate of change. Estimate the value for instantaneous rate of change at t is equal to 10 seconds. For instantaneous rate of change, we have done this before. We take the two close point. If this is 10, the close point is 10.0001, right? So I find h of 10.001 minus h of 10 divided by 10.001 minus, again, y2 minus y1 divided by x2 minus y. These 2 points are going to be very close. Use your calculator, that's going to be the instantaneous rate of change. Now, I'm going to go to one of the questions that is application here. Let's just do that. If weight is suspended from a spring, assume the friction, no friction or air resistance. When the weight is pulled down a small distance, it will oscillate indefinitely about the equilibrium position. So you have the spring. So this is the spring. I hope you know what is this spring. So you pull this one down. So it's a stretch, right? If you pull it down, it's a stretch. This spring, a weight is attached to it. There is an object attached to this spring. You pull it down, so it stretches, right? Stretch, and it's come, let's say here. So when it's come here, it's gonna be oscillate around your equilibrium point. Here, the equilibrium point, I put this one as a 0. Then it come back and gonna be compressed, right? Let's say this is, it's compressed. So it oscillates, come up and down like this. It oscillates around the equilibrium point, which is 0. So you put it down 3 centimeters. So here, from here to here is 3 centimeters. You put it down. Of course, when you stretch that much, this is going to be 3 centimeters as well. I know it's not a good picture because this is smaller than that, but just assume this is the same as 3 centimeters. I didn't have a space to correct it. Anyway, so the minimum is -3. This is your 0 equilibrium, and the maximum point is 3. After 1 second, it will back at equilibrium. So at 0 second, it is all at equilibrium. It is kind of neutral, is that. And 1 second, it will back to the equilibrium. Means it will go to your maximum. Well, actually, you started at 3 down. So your starting point is 3 down here. After 1 second, it will go back to the equilibrium right here. And 2 seconds, it will be 3 centimeters. So after 2 seconds, so here is 2. At 2, it will go 3 centimeters above. The 2 seconds, it will be 3 centimeters above the equilibrium position. At 3 seconds, it will be back at equilibrium. Now at 3, it will be back at equilibrium. At 4 seconds, it will be below again. Here is 4. Again, at 4 seconds, it comes to the minimum. So from the information given, first you need to draw the picture. Then find the equation of the sinusoidal function. So you already know that the cosine start at maximum. So you need to know the cosine. Here is y is equal to cosine x. But here is start at minimum. What happened if you flip that like that, right? Then the starting point is minimum. So basically the red one is y is equal to negative cosine. So negative cosine is a good model, but we need to have a period, amplitude, and later on. So the general equation is y is equal to a, I use cosine, I decide to use cosine. You could use a sine, but here, k x minus d plus c. Since I decided for cosine, to do the cosine here, my a gonna be what? Negative, but a gonna be my amplitude, right? Amplitude. What is the amplitude here? The amplitude is distance from maximum to the axis of symmetry. That's gonna be my amplitude. What is that? Is 3. Cosine k. K is related to the period. So k is equal to 2 pi over period. What is the period here? Is a full cycle from 0 to 4. So he start from minimum and then go back to minimum. So this is minimum to minimum. Any two symmetric points, the distance between two symmetric points going to be your period. So the period here is 4. 2 pi over 4. You simplify, it's going to be pi over 2. This is your k. This is pi over 2. How about d? Since this is a start at minimum, right? Or negative. So just, I forgot the negative. There is no phase shift. It's just at 0, like 0x. There is no phase shift. So it's just a pi over 2x plus c. Do we have any? So c is axis, right? Axis of symmetry. Here, my axis of symmetry here is on 0, right? That is axis, the midpoint between the maximum and minimum. So it's 0 here. Let's say I wanted to do the sine. What would happen then? If I wanted to do sine function, I know the sine start as 0, 0. It's like that. Now, see here, the 0 started where? There. See, this is go up and this is full cycle. Again, I'm gonna be y is equal to a sine k x minus d plus c. So here my a would be 3, no change. Sine what? K not gonna change. Just again, the distance between two symmetric points gonna be 4. And the k, I calculated the same, pi over 2. But here we have phase change. See here it started as 0, 0, but I have to shift this one back here, right? Means how much you shifted. If you had it here, how much is was shifted? It's shifted by 1. So to the right or left, it's shifted to the right. So it's going to be x minus 1. C is 0 again. So I got the equation. Do you have any question? Let's just do. So here is said, find the distance of the weight when the time is 1 second. See, instead of the x, you put 1.5 second, use your calculator to find the y. Or you can use this equation and put the x to be 1.5 second. Both are things. I recommend you to take a screenshot of this. Let me just bring it back. So the question I want you to work on is question number 2. And question number 5. 2 and 5 pretty much. Yeah, 2 and 5 is and 10A, the first one, and B. So 10AI and B.